Hey guys, today we're going to focus on how to graph linear equations and how to transition what we already know about linear equations into linear inequalities, kind of what we've been focusing on for the last couple lessons. So the first problem today is 9-65. It was a quick little review of how do we graph linear equations? What's the y-intercept? What's the slope? What does the slope mean in terms of the graph of the function that we've been given? So for this one, when we graph the linear equation y equals negative 2/3 x plus 5, the first thing we obviously want to make sure is that we have it in slope-intercept form, meaning that the y is all by itself, like y equals mx plus b. In this case we do, so we can start identifying our key components. Our y-intercept will always be our b value. In this case it's a positive 5, so our y-intercept is located at 0, positive 5. We would also identify our slope, aka the coefficient of x, the number that's multiplying the x value in the problem, if the y is all by itself. In this case we have negative 2/3. We write that negative 2/3 always as a fraction. In this case it already is a fraction, which is helpful to us. And then we say rise over run. In this case we have a negative rise value, which means we're going to be rising down 2 and then a positive 3, which means we're going to be running to the right a positive 3. With this information, I can then graph the 5 key points that I need in order to graph a complete function. So I draw my coordinate plane. I'm going to do my little ticks. Probably 6 in every direction. It's a lot easier if you have graph paper. All right, or thereabouts. We're going to now go ahead and start. We always start with our y-intercept, so I go up to the positive 5. Draw a dot up there, that's my y-intercept. I'm going to go down 2 into the right 3, down 2 to the right 3, draw my key dot, down 2 to the right 3, and draw another key dot. Now I'm also going to go in the opposite direction, right? So we can't just go to one side of the y-intercept, we have to go opposite as well. The opposite of going down 2 is to go up 2. The opposite of going right 3 is to go left 3. So I'm going to go up 2, left 3, draw my dot over there, and then up 2 more, right about there, and draw my dot over here. All right, now I'm going to take a straight edge of some sort and connect these dots with each other. You probably shouldn't use a school graphing calculator, but I trust myself to not draw on it. So I'm going to now connect all my dots, arrows at both sides, because it does continue on to infinity in both directions. Because we know it's a linear equation, it's a linear function, it will always continue. The next couple of questions that this problem asked us was to interpret certain numbers on our linear equation, but doing them algebraically. So the first one that it asked us is negative 3, 7 a solution? And then to prove that algebraically. This one is going to end up being a solution. What we always start by doing is rewriting the original equation and then identifying the x and the y that we're going to need to plug in order to solve algebraically to see if the left side of the equation will become equivalent to the right side of the equation, if they'll even out or level out, if you will. So here we plug in the number negative 3 for the x and the number positive 7 for the y. Don't forget to label them, otherwise most people will switch them and plug them into the wrong place in the equation. So we have negative 2/3 times negative 3 over here. Negative 3 times negative 2 is positive 6. Divided by 3 is 2. That's how I got the positive 2 right here. 2 plus 5 is... 2 plus 5 is 7, and therefore we have 7 equals 7, which is a true and valid statement, which means that yes, this number, negative 3, 7, is a solution to this problem. You could have also seen that by looking at the graph at negative 3, 7. Is 9, 1 a solution to this linear equation, linear function? Let's prove it. Well, we take that 9, 1, plug it into the x and the y values in the corresponding parts. Negative 2 times 9 is negative 18. Divided by 3 is negative 6. Negative 6 plus 5 is negative 1. and that is not equivalent to our positive one that we had for our initial y value. So no, 9 comma positive 1 is not a solution to this function. So this is the difference between proving it algebraically, plugging in the numbers, and solving it graphically, creating the graph and possibly even creating a table of values to go along with it to see what the values were. So the last question that number 65 asked us was, how do you determine the solutions for a linear equation? So the first question, there's actually two questions here, obviously. The first question, how do you determine the solutions for a linear equation? And then the second question is, where do they have to be located? So the first question, how do you determine the solutions for a linear equation? The solution, or the answer for this one, should be you plug in the x comma y values into the equation it's off center. You plug in x comma y values into the equation to see if the equation is equal. I guess maybe equal on both sides, we could say. Probably should have used the word equivalent, but that's fine. If the equation is equal or is equivalent on both sides. So that's how we can solve it algebraically. Now the second question, where do they have to be located in order to be a solution for the line, for the linear equation? The coordinates x comma y, whatever coordinates we're given here, they must be located on the line itself. It can't be above or below the line. So the coordinates, the x comma y, every single one of them, x comma y's, must be located on the line itself, not above or below. If we look back at our graph that we just drew, we could very clearly see that negative 3 comma 7 was located on the line itself. Whereas if I were to extend my graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 comma 1 is very clearly not located on the graph of the line itself. Okay, so we need to be very clear that there are two different methods to do this. One is to solve it algebraically, and the other is to solve it graphically. But we have to be able to prove it in both methods.